Okay, so full start. A reminder for those of you who haven't filled in the Google article, like we won't be able to do the work.
Yeah, the link today.
And this is done by tomorrow afternoon. I'll run the script generic for code. Okay, so in the first lecture of today, I want to talk about cloud computing. First of all, I'm going to apologise. Normally, in the last 2 years, I haven't done this lecture. We've got someone from IBM who works in the cloud services division at IBM, and he's coming to do it. Unfortunately, wasn't available this year, so it's kind of fallen to me. Luckily, I kind of know the context, so I'm going to try and get across all the key points. But yeah, I'm not really the expert, so I'll warn you of that now. Okay, so first of all, what is cloud computing? Well, you recognise our little marketing guy, depicted by Dr. over there. Well, cloud computing is a bit of a marketing term, a marketing gimmick. But it does have some technical value as well. Cloud computing fundamentally is a different way of providing computing services. Not a new technology. By no means is it a new technology. It's just a collection of things that already exist put together. In some ways, it's about using computing like you would a utility like water or gas. Computing on demand, computing that you pay for what you use. If we look at what the cloud provides, what it is. Well, so cloud is end user focused. So it's all about you being the end users. Okay, it's about making life easier for you. In what way? Well, it saves you from having to perhaps look after the hardware. It's about buying the hardware and using the provision it yourself to your operating system. It is about you being able to control virtual machines that someone else looks after the hardware for you. If the hardware fails, they replace it. It's not your problem. So it makes your life easier. So it enables self-service. So it means that you go out there, you can access computing power remotely. You can spin up more computing power when you want to. So it gives you economies of scale. There are different types of cloud. I'm not really going into as much detail, but when we talk about cloud computing, you have to bear in mind that there are the public cloud, things like Amazon AWS, it's a big cloud service that you can use. But there are other types of cloud. IBM sells cloud in a box. It's literally a stack of computers that you install in your data center. They're your computers, you buy them from IBM, but it's still a cloud. Okay? There are different ways of doing things. There are different types of cloud in terms of the programming rules. We're going to look at some of those later. So there are many different aspects. It's built on, as I already said, it's built on existing technologies. So it takes some things like virtualization. We'll look more at that in detail at that in a bit. It takes things like service-oriented architectures. So the idea of software components that talk to each other, but run independently. Service management automation. So that's the idea of software tools that manage other people's software. Software tools that monitor continuously the state of your systems. They tell when it crashed and restart it. They tell when the hard drive fails and get someone to replace it. Okay, so it's about automating all of those processes. It no longer relies on you having a sysadmin whose day-to-day job is checking that these things are still running. It's all automated. Usage tracking and billing. So that's another big part of that. You as the customers of the cloud service, you pay for what you use. From the point of view of the person running the cloud, well, that's how they're making money. Okay, so they want to track who's using what, how much they're using, and then they're billed accordingly. Web 2.0, so interactive web applications. They are what power the cloud in many ways. And we'll see an example of that in a minute. So what's new? What does cloud bring on top of these things? Well, there's a key focus on self-service. That means that you can go along and you can buy into the cloud and you can request machines, you can spin them up, you can use them for as long as you want, and then you shut them down when you're done. You don't have to ask anybody, it's all done through web interfaces. Okay? And you're paying for what you use. So that's really what cloud computing is about. Why is it good? Or why can it be good? Well, the idea is that with cloud computing, we can make far better use of existing computing resources. If you want to deploy a website and host it on the internet, there are lots of different ways in which you could do that. At one extreme, you could go out, you could go to Dell, you could buy a server, you could find somewhere to host that server, whether it be in your house or whether you pay for someone else to host it for you. You can plug it in, you're going to pay for the electricity, you're going to pay for the internet bandwidth. For the internet bandwidth, you're likely to pay a fixed sum for a certain capacity of bandwidth. If you exceed that, you're likely to pay a lot more. Most of the time, your server is going to be sitting there idle. It's not going to be doing anything, because your website is probably not going to have a continuously high load. So it's not very useful, not very efficient use of that piece of hardware that you've invested your money in. Cloud computing is all about making the most of that hardware. So it's all about taking pieces of hardware and making them work at 80-90% of their maximum capacity. It's about making them work all of the time. So when you're not using your piece of cloud computing, someone else is using it for their thing. So it enables a number of things. So utilization increases, using the computing much more efficiently. Self-service, so the fact that you can remotely request more of the service. You've got with respect to things like provisioning, you've no longer got the issue that when you had to order the computer from Dell, you had to wait 3 weeks for it to arrive. You can now go to the cloud service provider and you can get it instantaneously on transfer of your credit card details. This enables other things. So it enables change management, more rapid change management. If you want to change something in the way your application works, you do it instantaneously. If you want to scale your application, all of a sudden one server is not enough and you want to go to 2, there's not a 3-week turnaround whilst you wait for the new server to arrive. You do it instantaneously. This means you can be more rapid in terms of your development. You can release new versions of software more often. You can test them better as well. Because no longer do you have to have a server that is running continuously, hosting your website, plus another server to maybe do the testing and continuing configuration. You could use the cloud, and when the continuous integration server is not running, when you're not running a new beta, you can shut down the service and you're paying for it. So there's many advantages of cloud computing. When we get to the end, we'll look at some of the disadvantages. If we look at the sort of cloud landscape, you can see that it's kind of split into 2. There's the cloud users and there's the cloud providers. I consider you to be the cloud users, those people that are developing the application and using the application potentially. They're cloud providers, or they who look after the hardware, and The interface between you, the users, and then the providers is usually some kind of web application or some kind of web service API with tools that you can perhaps use in the command line. So, from your point of view, what do you need? Let's take a scenario. Let's assume that you've got an online auction app, eBay 2.0, for example. And let's say you want to deploy this application. So your app's got a front end, it's got the website, it's got the business logic, so the things that count down the amount of time remaining to figure out who won the auction, all that stuff. And you've got a database, because that's keeping record of everything. You want to deploy this application to the cloud? Well, what do you want? What does the cloud need to have with it? So the thing that you provide the cloud with, first and foremost, are images, disk images. These disk images contain the operating system and all of the software that you want to run. You might have different disk images. You might have one for your database, so a operating system plus a database server. You might have the web server, so maybe Apache plus all of your HTML files, plus whatever application server that you're using. There might be different images, they might all be on one. Depends on how you want to scale. In terms of scalability, you might set your images up to be templates, so you can create new instances dynamically, so you can scale your application. So maybe you have an image of database slaves. So you have a master database which controls everything, so you have multiple slaves, and if you get more and more load, you get more and more users, start to make more and more money, maybe you need your application to work faster, you need more database power, so you add more slaves. So you've got a set of images that enable you to provision your app. In terms of the other side, once you've got your images, you need to run or create instances. So these are running versions of those images. They're essentially virtual machines. And each of those instances has an amount of processor. It's got memory, it's got network, it's got some local storage. The neat thing about this is that you can control how big your instances are. You only pay for what you need. So perhaps when you're deploying your application for the first time, you're not really expecting there to be too many users. You're going to kind of hope that you've got a plan, maybe you've got a marketing plan for a relatively slow uptake of your system. You want to reach 1,000 users in a month's time. There's no point in paying for really big servers. It's just a waste of money. Start small and grow. That's what the cloud lets you do. So you choose the sizes of the servers that you want. You can change them later, trivially, but you're in control. Okay, so each of these instances running on these servers has an amount of local storage attached to it. There is something to bear in mind. This local storage is ephemeral. The moment that the instance is terminated, the storage goes away, and every piece of data that was written to it is lost. So how do you get around this? Well, in the cloud, you provision the database to be on a different type of node, type of instance. So perhaps that you never turn the database off, you never turn the database server off. It's got persistent storage, whereas the instances which are serving the web application, they're allowed to shut down. Okay, so there's different types of, in some terminology, they'll be called workers. Okay, so there's different types of workers for different applications. Some of them have persistent storage, others won't. When you create your instances, you obviously want to secure them. You don't want other people to have to log into them and shut them down, or manipulate them, or do anything at all. So typically what you do is when you create your images, and you upload your images to the cloud console and you sign them with the public key, only you with your private key can access them once they're deployed as instances. This is the typical approach. Well, networking. So you're hosting a website. You're obviously going to set up DNS so you can access it via a nice name, but it's going to have an IP address associated with it. ideally you want a static IP address, so if there's a problem with DNS, you can get to it anyway. Well, there's a little bit of a problem here. Your instances, they have IP addresses, but every instance has a different IP address. You can't, in cloud computing, you can't rely on you always having the same instance. So, for example, if you pick an instance, you deploy your application on it, at some point in the future you shut down that instance, you terminate it, and then you spin up a new instance, you're going to get a new IP address. So all of the big cloud platforms, they deal with this by giving you virtual IP addresses. And this diagram kind of illustrates what these virtual IP addresses can do. But the key idea here is that your virtual IP address will point at a machine. Should that machine shut down, it can then point at a different machine. So it gives you automatic failover. Something crashes, the machine goes down, your site still works. Some of the big cloud providers do things like load balancing. So load balancing will give you one IP address publicly, but behind the scenes, different IP addresses will serve your requests. So you have a whole stack of different servers. They're all running the same application, but they're all serving different groups of users. Okay, so that's looking at your point of view as the user. What about from the point of view of the cloud provider? What do they need to do? Well, they need to, first of all, have a web application or some kind of application in order to give you the access, to give you the self-service access. And they also need to manage infrastructure. They need to make sure that if a hard drive crashes, that it doesn't impact your business. Because if it impacts your business, then they'll lose their business. So how do they do this? There's a number of factors that they take into account. So first of all, they virtualize everything. So it's not real hardware, it's all virtual hardware running on real hardware. If something fails, they replace it. As far as you're concerned, it's pretty seamless. The only thing you might notice is that one of your instances running instances gets transferred from one machine to another and IP address changes, for example. In terms of the cloud provider, though, the other thing they need to ensure is that all of the machines that they've invested money in are working at capacity. If their machines are sitting there not doing anything, then they are losing money. So this is a bad situation to be in. So they only need they want to be in a position where they buy as many machines as they need to service their customers and no more, perhaps with a little bit of leeway for dealing with crises. Okay, so what about on the other side? So that was kind of the hardware side. But what about on the other side? Well, self-service again. So they want the cloud provider wants to be able to make things as seamless as possible for you. They ideally don't want you to give them a call and ask for help. They want things to be as much as you doing it all by yourself as possible, minimizing the amount of support. They want to manage, automate as much of the management as possible. So, should you go and request a new instance, they don't want someone to physically have to go and plug a computer in, for example. That would be a waste of time. They want it all to be completely automated with software. They want standardization of workloads. So, if you're developing a cloud application, they want the workloads to be the same. They want you to both go to the same console, do the same things to request instances. They don't want to have specialized things for each of you, because that requires more management load. So they want to keep things as simple as possible. So all of the big cloud providers have web interfaces. There's a screenshot, there of Amazon. Different ones, SoftLayer, so SoftLayer is IBM's cloud thing. They have this customer portal. Heroku that you're using in the coursework, they have an online dashboard. You know how to use it though. They've got a command line tool that uses web services to interact with the backend. So you can do everything in Heroku with the command line. You create, provision apps, spin up new instances, shut down instances, query instances, create databases, all of that you can do with the Heroku command line tool. So these are the kinds of things you're going to do. You know, you're going to create instances, spin things up, shut things down, attach some storage, create specific storage, delete specific storage, etc. Obviously, behind the scenes, the cloud provider has to have physical hardware, and they're going to have big data centers, really big data centers if you're Amazon. In order to make the most, so I've already kind of said this, but in order to make the most of those data centers, virtualization is the key technology, because it leads to efficiency savings, it leads to much more flexibility. If there's a computer over there, it's not doing very much, well, let's shift some load to it, kind of thing. It doesn't say so on this slide, but it leads to energy savings, because you're using, potentially you can shut down machines that are not being used. You can save power consumption, for example. You can create less heat. Ultimately, you can do good for the environment. So in terms of virtualization, this is the kind of thing that you, as a cloud provider, might want to set up. So standard virtualization. So you move from a model that looks like this, where you've got some hardware which runs an operating system, which runs a set of applications, potentially belonging to different users, different developers, to a model that looks a bit like this, where you've got hardware which has a host operating system, which is typically an operating system that's very, very lightweight. Its only purpose is to be able to run this thing called a hypervisor, which is a thing that runs virtual machines. And then, on top of this hypervisor, every application, it runs within its own virtual machine. Each of those virtual machines has got its own resources. So it's got allocated a percentage of the CPU, the physical CPU. It's got allocated a percentage of the physical RAM. Each one of those will have its own networking assigned to it. So probably virtualized networking, but every VM will have its own IP address. Each VM, of course, has got its own guest operating system. You, as the people that are buying into this cloud, you choose what that operating system is. This has some problems because it means that you've got to maintain it. Okay, so all the security updates that need applying to that operating system, that's down to you. So this is kind of a common model. If you go to Amazon AWS, and create some instances, this is the model that will be followed. Okay, and with AWS, you create your images with your operating system on, your application on, and you deploy them to the cloud, and they'll run on virtual machines, or as virtual machines on physical hardware. Nowadays, so things have changed a little bit. AWS has been around for probably about 10 years now, and it's still working in the same way. But nowadays, there's alternatives. And in particular, there's a different type of virtualization which is becoming really popular. It's operating system level virtualization. More often called containerization or jails. So for those of you who regularly use Linux has got a thing called a chroot jail. And this is a type of virtualization that lets you run applications within essentially a sandbox. They're inside a box that they can't get out of. An application has got access to a disk, and another application has got access to a disk. They can't trash each other's data. They're completely locked off from each other in these jails or containers. So graphically, it looks something like this. The advantage of this kind of approach is that it's less resource intensive. It's not that you've got a virtualized CPU or anything. You've got one physical CPU or multiple physical CPUs that are shared amongst your apps, but you've got these containers which stop them clobbering each other's data, stop them leaking information between each other, etc. The other advantage is that in this particular case, the cloud service provider is the one that looks after the host operating system, not you. That means that the cloud service provider will be the person who's in charge of all of the security updates, all of the maintenance jobs that need to be done with your operating system. As far as you, the application developer, are concerned, you just care about your application, and you just know that it's going to run in some kind of container, that it's secure, according to the SLAs provided by the cloud provider, that the fundamental thing is that you're really only in charge of your app. Okay, so up to this point, we've kind of considered that cloud computing really involves you creating images, spinning images up, and that's kind of like it. That's kind of all cloud computing is. Well, actually, that's not entirely true. That's a particular type of cloud computing. That's called infrastructure as a service, often written as IaaS. But there are other types of cloud computing. There's software as a service, SaaS, and there's platform as a service, PaaS. And these other types of cloud computing have different functionalities. They have advantages and disadvantages. So let's look in a little bit more detail. So platform as a service. This one's important because this is what you'll be using for the coursework. In fact, the Heroku cloud platform is a platform as a service. Platform as a service is a little bit different to what we talked about before. So in a platform as a service, you don't care about the operating system. The cloud provider provides you a way of running applications. You provide the cloud, so you create an instance on the cloud and you upload your application to it and it runs. But you don't have any control over the operating system. Why is this different? Why is it better than infrastructure as a service? Well, with infrastructure as a service, you have to deal with a lot more things. So we've talked about security updates. There's more. Things like scalability, availability. So making sure that your application doesn't crumble under a load of many users, making sure that it's always running. Your responsibility with infrastructure as a service. With platform as a service, the cloud provider is in charge of all of these things. They can deal with scalability on your behalf. So if your application starts to get overloaded with users, you can set the cloud up to scale for you. You give it your credit card details, it will spin up instances on your behalf and charge you accordingly. Persistence is dealt with by the platform. It's dealt with for you. So backups and things like that, backups of databases, you don't have to worry about that you're paying the cloud provider to do that for you. Security, obviously we covered that the cloud provider is now in charge of maintaining operating system security. You've obviously got to be in charge of any holes in your application, but that's it. In terms of the thing that your application is running in, let's say your application was a Java, an enterprise Java application running on an application server like JBoss or Tomcat, the cloud provider will be in charge of making sure that the version of Tomcat or the version of JBoss was the latest one. Okay, it's not your problem. You obviously have to trust that the cloud provider is going to do the right thing. Kind of the idea. So, benefits. Easy to get started developing your own application. Well, I hope so, because we can do this with the coursework. The cloud provider is going to do everything for you, pretty much. Does have some restrictions, though. Restricted or limited programming module. Say hello to Google App Engine. Don't say I didn't warn you. But to be honest, if the programming model lets you do what you need to do, then what's the problem? It's fine. Okay. Let's give a few examples. So I kind of mentioned GAE and I mentioned Heroku, but there are others that are common. IBM's Bluemix is a PaaS. You've got Amazon Elastic Beanstalk. So it's something that runs on top of EC2. It manages the images for you, and it just provides you with the application. The application engine layer. Actually, I should point out that Heroku does a lot. So Heroku is actually built on top of EC2. So even though for the course you're going to be using Heroku as the platform as a service, the back end of that, the bit that Heroku, the company, pays for, is actually running on EC2 instances with custom images. So it's all built in layers. Cloud Foundry is another service provider. And you can see all these different service providers, they all offer different combinations of languages. Ones like Heroku are fairly flexible. Ones like Google App Engine have some major restrictions about what you can do in those languages. Okay, so and yeah, graphically that's kind of the difference here. So quite literally, so I guess one thing I didn't mention is that within a platform as a service, you've got no guarantee that your application is running by itself in the virtual machine. It might be, but there's no guarantee of that. There could be multiple applications running in the same virtual machine. There could be multiple applications running in the same application server. So if you've got your copy of JBoss running, bear in mind you've got no control over it, you've deployed your web app, your WAR file, with your Java code in it, to the application engine. Someone else might have deployed theirs as well. They could both be running in the same application engine. You don't know. There are issues with that. We'll come to that in the end. What's the other side? So we looked at infrastructure, we looked at platforms. What's software as a service? So in this particular case, there's a piece of software you want to run, but you don't really want to pay for the server to host it, and you don't want to have to maintain that server. It's a waste of your resources, your time, your money. Why not pay for someone else to do it for you and just look after it? So that's what software as a service is all about. The idea of it being that you don't have to install anything yourself. Someone just does it for you. And there's lots of examples of this. But perhaps, so I mean, the examples here. Salesforce.com is a well-known customer relationship manager, online thing for managing your relationships with your customers. There's a few others, Office 365 and Google Apps. They're probably ones that you've all used. There's another one that you're all going to use if you haven't used it already. GitHub. That's a software as a service. It's a website that hosts a Git server essentially and provides you with lots of extra bells and whistles. But it's something that piece of software that you don't have to run for yourself. Someone's running it on your behalf essentially, and they're going to use it. So, in terms of software as a service, as far as you, the users, are concerned, there's the only thing you know about is the application. So, take GitHub. You've got no idea what GitHub is running on, what hardware it's running on, what operating system it's running on behind the scenes. You don't care, to be honest. You just don't care about those things. You don't care about what application server it's running on. Until it breaks, perhaps. Behind the scenes, well, again, it could be that your access to that application is completely maintained by a single VM, which is only running that application. But it could equally be that there's lots of people sharing the same application service, sharing the same VM in using that application. Potentially, it means that your data and someone else's data are stored in the same place on a server somewhere. So there's always going to be a trade-off with these different types of approaches. With infrastructure as a service, you've got total control that you have to manage everything yourself. With software as a service and platform as a service, you get things managed for you, but there are risks. The data that you create, that you store, is potentially shared stored in the same place as other people's data. If you're not careful, there's a risk that the data could leak out and leak between applications. Virtualization, operating system level virtualization deals with this to an extent, but it's not the end of the story. One thing you probably have to be really careful of is things like error logs. So, as an example, let's assume you've got a Java web app and you're deploying it to JBoss. If your web app has got some logging things in it, then whenever you make logging messages, that will go to the JBoss error. Now there are ways of configuring JBoss so that all of the errors from your application go to one log file, and all errors from another application go to a different file. But equally, the standard default configuration will send all of the log messages to the same file. Now let's assume that your application is maybe leaking credit card details into the log, something with less errors, part of the development process that you forgot to remove. Potentially, someone else could see that log and would see all of that information that you've leaked, and it would be a big problem. In fact, you'd probably be liable. So there's risk. Maintaining separation of the data is difficult. Performing encryption is difficult as well. Certainly end-to-end encryption can be difficult to configure because you've got very little control. What about another issue? This is particularly one that would occur can occur with Java applications. You've got multiple Java applications running in the same application server. One of those Java applications throws a bit of a hippie fit and starts to consume all of the memory. Pretty typical of Java. Unfortunately, not only does it affect that application, but it could severely affect all of the other applications that are running within that same application server, to the point at which they become unusable. So, your application is adversely affecting someone else's. And you're both paying for the service, you're both paying potentially the same amount for the service, but because of a problem on your part, perhaps, you're destroying the ability of someone else to use that service. So that's another issue. Just to sort of summarize, so there are a lot of risks that need to be considered carefully when you're deciding whether you should go down the cloud computing route. And I think they can be summarized here. So the first one is control. Control of the data, control of the information, regulatory control. So you're deciding to put an application that stores health information in the cloud. You probably want to think very, very carefully about whether you're even allowed to do that, because the rules surrounding personal health information and how it's stored are very, very strict. So you won't be allowed to use the cloud. Data. So you're copying data somewhere else. You're giving it to someone else to look after. That potentially puts you at increased exposure of risk for having unauthorized people look at the data, having unauthorized people steal the data. How do you deal with that? Reliability. If you've got your own servers, you're in charge of making sure that they're working all the time. You can employ someone, or potentially at great expense, you can employ someone to make sure that they work. Potentially, you can invest in having things like hot backups so that you can continue your business critical jobs at will. With the cloud approach, you potentially have that, but really it's at the whim of the cloud service provider. As soon as they stop supporting the cloud, as soon as they start to fail on keeping the cloud running as smoothly as possible, it's not really them that's impacted, it's you, because it's your application that breaks and stops working. Compliance, okay, so we kind of covered that with control, but compliance, maintaining regulatory conditions is an issue. Security management is kind of the final one, and it's kind of important as well. Cloud computing, as you've kind of already seen, is built up of many layers. Okay, many, many layers, where you've got virtualization, potentially you've got containerization, you've got application servers, all these different layers of software. And security is obviously a big concern. And for an application to be secure, it needs to be secure at every one of those levels. If the operating is not secure, then anybody can steal your data. If the application engine has vulnerabilities that enable people to get root access, then your data is not secure. With all of these layers, it makes it very, essentially very obscured. Again, it's very difficult to tell whether anything is secure at all, and makes it even more difficult to fix. So that's that's kind of the final risk to consider when considering whether you should use cloud services. Okay, that was the last slide. Are there any questions? Is there anything anybody wants to ask about cloud computing or anything else? No? Okay, so we'll end there. As a reminder now, there's a few more of you in the room. If you haven't signed up for with your GitHub details on the Google form, do it today. Otherwise, you won't have access to the course once it's done. On Thursday morning,